Good day everyone, I hope you are doing well. Today we will be discussing another lesson which is difference of two squares. For our objectives, at the end of the discussion, you will be able to determine whether the given binomial is difference of two squares, associate difference of two squares into sum and difference of two binomials, factor difference of two squares, and explain the procedures on how to factor the difference of two squares. So before we proceed to our main lesson, let us recall how to get the square root of a number and monomial. Find the square root of each term. What is the square root of 16? The answer is positive and negative 4. Why positive and negative 4? Because if you get the square of 4, so we have 4 squared, the answer is 16. So as the square of negative 4, also 16. So therefore, the square root of 16 is positive and negative 4. How about 81? So the square root of 81 is positive and negative 9. 25x squared. So the square root of 25x squared is positive and negative 5x. The square root of 64y raised to 6 is positive and negative 8y cubed. Lastly, the square root of 121x raised to 4y raised to 8 is positive and negative 11x squared y raised to 4. So let us now proceed to our main lesson, which is difference of two squares. So before we factor difference of two squares, we have to identify if the given polynomial is an example of difference of two squares. So here are the tips to identify the polynomial that is difference of two squares. First, the operation involved is subtraction. Second, the exponents are even numbers or divisible by 2. The numerical coefficients are perfect square. Lastly, one term is positive and the other term is negative. So what we have now are examples of DOTS and non-examples of DOTS. So let us observe and identify what makes a polynomial an example of DOTS. So let's have the first pair of polynomials. We have x squared minus y squared and x squared plus y squared. X squared minus y squared is an example of DOTS because the operation between two terms is subtraction, while x squared plus y squared is not an example of DOTS for the operation between two terms is addition. Another pair of polynomials, we have 25 minus g raised to 6 and 25 minus g raised to 5. So as you can see, the difference between the two is the exponent of the second term. We have here g raised to 6 and we have here g raised to 5. So what makes 25 minus g raised to 6 an example of DOTS is g raised to 6 is a perfect square. So how do we identify if the variable is a perfect square? By just simply looking at its exponent. If the exponent is even number or divisible by 2, it is a perfect square. Therefore, g raised to 6 is a perfect square. While g raised to 5, as you can see, the exponent is an odd number, therefore it is not a perfect square and not an example of DOTS. Let's have the third pair of polynomials. We have 36x raised to 4 minus 49y raised to 10 and 6x raised to 4 minus 49y raised to 10. So the difference between the two polynomials is the numerical coefficient of the first term. As you can see, we have here 36 and for the second polynomial we have 6. So what makes the first polynomial an example of DOTS is that 36 is a perfect square, while 6 is not. Therefore, 36x raised to 4 minus 49y raised to 10 is an example of DOTS, while the other polynomial is not an example of DOTS. Last pair of polynomials, we have negative 64a raised to 4 plus 81b raised to 6 and negative 64a raised to 4 minus 81b raised to 6. So the reason why the first polynomial is an example of DOTS is because one term is positive and the other term is negative. As you can see on the second polynomial, they are both negative. Therefore, it is not an example of DOTS. Now let's have these exercises. Identify if the binomial is an example of DOTS. We have 9b raised to 6 minus 4. So it is an example of DOTS because as you can see, 9b raised to 6 and 4 are perfect squares and the operation between them is subtraction. How about c squared minus 2d raised to 4? It is not an example of DOTS because 2 is not a perfect square. How about negative 123 plus 36m raised to 8? Again, this is not an example of DOTS because 123 is not a perfect square. Number 4, s squared t raised to 7 minus 16m raised to 4. Not an example of DOTS because t raised to 7 is not a perfect square. Lastly, negative 24x raised to 4 y squared plus 49. Again, not an example of DOTS because 24 is not a perfect square. Now that we know how to identify if the given polynomial is an example of DOTS, let us proceed on factoring difference of two squares. So how do we factor difference of two squares? So let's have the following steps. First, write two quantities just like this. After that, get the square root of the first term. Next, get the square root of the second term. Lastly, follow the operations pattern, so you may use addition first before subtraction or subtraction then addition. Let's have the first example. We have x squared minus y squared. So to factor this, first step is you have to write two quantities. So we have two quantities. Then after that, get the square root of the first term. So the first term is x squared. So the square root of x squared is x. Place the result to the left side of each quantity. So we have here x and we have here x. Next is to get the square root of the second term. So the square root of y squared is y. Then place the result on the right side of each quantity. So we have here y and y. Lastly, we follow the operations pattern. So we put here addition. Then for the second quantity, we put subtraction. You may also write your factored form as x minus y times the quantity x plus y. So they are just the same by commutative property of multiplication. Let's try another example. What is the factored form of 25 minus g raised to 6? So the first step is to write two quantities. Next is to get the square root of the first term. So the first term is 25. The square root of 25 is 5. Then place the result on the left side of each quantity. Next, get the square root of the second term. So the second term is g raised to 6. So the square root of g raised to 6 is g cubed. Then place the result on the right side of each quantity. Then last step is to follow the operations pattern. So let us use the addition and subtraction. Or you may write your answer as quantity 5 minus g cubed times the quantity 5 plus g cubed. Now let's have the third example. We have 36x raised to 4 minus 49y raised to 10. So the first step is to write two quantities. So we have here two quantities. Then after that, get the square root of the first term. So we have a square root of 36x raised to 4. So the answer is 6x squared. Then after that, write the result on the left side of each quantity. Next is to get the square root of the second term. So we have a square root of 49y raised to 10. So the answer is 7y raised to 5. Then, write the result on the right side of each quantity. Last step is to follow the operations pattern. So we have addition and subtraction. You may also write your answer as quantity 6x squared minus 7y raised to 5 times the quantity 6x squared plus 7y raised to 5. Let us now proceed to our last example. We have negative 64a raised to 4 plus 81b raised to 6. So as you can see on our given example, the first term is negative. So how do we factor this? So what we have to do is to rearrange the polynomial. What do I mean by that? Meaning you have to write the second term first, followed by the first term. So our polynomial will become 81b raised to 6 minus 64a raised to 4. Then after that, we will go back to the usual process in factoring difference of two squares. So first step is to write two quantities. Get the square root of the first term. So square root of 81b raised to 6. So the answer is 9b cubed. So place the result on the left side of each quantities. Next step is to get the square root of the second term, which is 64a raised to 4. So the answer is 8a squared. Then write the result on the right side of each quantity. So we have 8a squared and 8a squared. So last step is to follow the operations pattern. So we have addition and subtraction. Now your turn. Identify whether the given binomial is an example of DOTS or not. If the binomial is DOTS, write the factored form. If not, explain your answer. So you may pause the video and try to answer the following. Number 1, f squared minus 4. So it is an example of DOTS and the factored form is quantity f minus 2 times the quantity f plus 2. Number 2, 2g squared minus 9. So it is not an example of DOTS, for 2 is not a perfect square. 3, 16h raised to 4 plus 25. So not an example of DOTS because the operation is addition. Number 4, 9i squared minus 49j raised to 6 is an example of DOTS, and the factored form is quantity 3i plus 7j cubed times the quantity 3i minus 7j cubed. Lastly, we have j cubed k raised to 4 minus l raised to 6 m raised to 8. So it is not an example of DOTS because j cubed is not a perfect square. With that, thank you for listening and I hope you learned our lesson for today. Stay safe and God bless.